Hello, hello, hello. Okay, so the audio is working fine, and today I will be live solving educational code forces around 162. And initially, the stream will be private, and once the stream is done, sorry, once the contest is over, I will make it public. So you will be able to hear my thoughts, what I am thinking while solving the problems, and I will use open board for writing and the Sublime text for coding. Okay. And I will code in C++ or Python, whichever I prefer at that point of time. So that is that, and now we have to wait 1 minute for the contest to start. Okay. If you want, you can check out my graph algorithms playlist. So I'm working on it, and if you want a particular topic, if you want me to include a particular topic, you can tell me in the comments here, and I will include it. Okay. Now let's actually wait for some time, and I think I will do it on m2.codeforces. Okay, 50 seconds remaining. Yeah. Okay, there is a ribbon divided into n cells, the numbered from 1 to n from left to right. Each cell either contains a chip or is free. You can perform the following operation any number of times, possibly 0. Choose a chip and move it to the closest free cell to the left. Okay, you can choose any chip that you want, provided that there is at least one free cell to the left of it. When you move the chip, the cell where it was, okay. Your goal is to move the chip in such a way that they form a single block without any free cells between them. What is the minimum number of operations you have to perform? Okay, I think this is a standard problem, and basically we have to get the position of every one and get the median position, and then we want to find the. I mean, like if we have let's take this test case 1 0 1 2. Okay, let's have 0 1 1 1 0 1 1 0. Okay, so this is actually very similar to this problem called from CSES. Like I will just show you. So there we have a problem called stick length. Where is it? Yeah, this is the problem. So when you want to minimize the task, so it is actually bijection between this problem and that problem. So if you want to minimize the cost, basically what we do is like we number the positions. Let's say 0 1 2 3 4 5 6 and 7. Okay, and then let's take the minimum median of the position. So one is this 1 2 3, then 5 and 6, and what is the median position? 0 1. So the median position is 3. So we want to have the block whose median position will be 3. So I can say okay, these two are here, and now we want to bring these two to this position. So I think the answer is 2 for this test case. Where are we getting a 1? Print the minimum number of operations you want to perform. So in the first example, you can perform the operation on 7th cell. Okay. Okay. So I think I get it now. Uh, I, because we don't even okay, so this is not that problem. We don't want to minimize the. Okay, the cost is not defined as the number of. I think I read the problem wrong. The cost is not the number of spaces that character moves. So we don't need to do that. Okay. Here in this case answer is 0. In this case also the answer is 0. But okay, let's say we for a 1. I think we first need to find the maximum block that we can find, and then the answer is simply, I think, the distance between, minimum distance between these blocks. So if we have, like, we had two zeros here between the blocks, so the answer is that. In here we had 1 2 3 zeros, so the answer is 3 for this test case. Yeah, I think I get it now. So basically we want to find the maximum gap that we can get. So for that, let's say int n, say in n, vector int a of n for I, say in a of I. Now first of all, let's say int I equals to 0, and then what I will do is I will keep traversing till I find a 0. So I can say, like, while a of I equals 0, I plus plus. Now I can say while a of I equals 1, uh, I plus plus. So now I am at some stage where I have skipped all the starting zeros. Now I skipped all the starting ones. Now I want to count the number of zeros that I will get. Okay. So basically what I can do is I can say, okay, what I will do is for I in range this, now I can skip the definition of I because I have already calculated that. And now I've skipped the first block of ones. So now I will say my int answer is equals to 0, obviously. Now whenever I find zeros, like if a of I equals let's say 1, then I will do something else. Else what I can do is I answer plus plus, and obviously because obviously I don't want to consider this test case this 0, so I will say continue for now. Now I've calculated the I need to minimize the end 0, so let's say int I is equals to I mean at this stage my I will be equals to n minus 1, so I will say while a of I equals 0, I will say count minus minus and I minus equals 1, uh, and then see out answer and l. Will this work? I'm not sure. uh, I should say answer minus minus, not count minus minus. That was my mistake. I should copy this whole test case. Okay, we are getting some wrong answers. Okay, so the answer should be, first of all, my answer should be 1 for this test case. Why are we getting 0? Let's try to debug this. Okay, so we have, what is the value of let's say for this first test case only, what is the value of I? I is 0. Why is it 0? While a of I equals 0, uh, I will say I plus plus, that is correct. Wait a second, did I take the input wrong? Okay, I is 4, 0, 1, 2, 3, 0, 1, 2, 3, 1, 2, 3, and 4. So I am at here. Okay, now my answer will be 1. Then I will skip all the zeros. I think in here the answer should be let's see. Okay, so I is 4. My answer is 8 actually. Let's say I minus minus. Okay, now we are getting some correct answers. Let's say debug this, and we are getting 0 1 0. Okay, it should be 5. So now we are getting 3, and I should now just remove all the debug statements. Yeah. Okay, so now we are getting correct answer. Let's try to submit this and see if it works. Okay, so we got a correct answer. Let's move on to the next problem, that is monster attack. You are playing a computer game. The current level of this game can be modeled as a straight line. Your character is in point zero of this line, and there are n monsters trying to kill your character. The ith monster has health equals to a of I and is initially in the point xi. Okay. The current level of the game can be modeled as straight line, and your character is at point zero in this line. Okay, and there are n monsters trying to kill your character. The ith character has health equals to a of I, and which is initially at point xi. Uh, every second, the following thing happen. You fire up to k bullets at the monster. Each bullet targets exactly one monster and decreases its health by one. Okay. For each bullet, you choose the target arbitrary, and for example, you can fire all the bullets at one monster, fire all the bullets at different monster, or choose any other combination. Any monster can be targeted by a bullet, obviously, and regardless of its position, uh, and any other factor. Okay, then all the alive monsters with health 0 or less die. Okay, then all the alive monsters move 1 point closer to you. The monster to the left, or you increase their coordinates by 1. The monster to the right of you decrease their coordinates by 1. If any monster reaches your character, you lose. Okay. Can you survive and kill all the n monsters without letting any of them reach your character? Yeah, I think this is a good problem. Okay. Okay, let's try to actually visualize this. What we have here. So we have what is the input format? First we have n and k, int n comma k. So scene n and k. After that, each of the test case consists of three lines. First is the two integers n and k. Then we have n integers. So vector int a of n for I, cn a of I. Yeah. So we have this. Now what? Then the third line contains an integer xn. Okay, vector int x of n for I, cn x of I. Okay. So we have the integer. These are the coordinates of the n monsters, and this is the health of the n monsters. Okay. So now we have n is 3, and what is k equals to 2? What does k represent? I forgot. Hmm. Okay, you can fire up to k bullets at the monsters. So I think it is optimal to just fire all the bullets and in a single. Every second I can fire up to k bullets. Okay. That is not the total number of. Okay. So if I am at x equals to 0, let's say I have a big line, I am at 0, then the coordinates are -1, 2, and 3. So let's say -1, 2, and 3, and the health of the monster is 1, 2, and 3. So 1, 2, and 3. Okay, and like what will be the case when this monster will not be able to reach me? The closest monster will not be able to reach me. If I don't want to mess with this monster, I mean, there is a bound on like what is the time complexity that is required here? Sum of n does not equal 3 into 10 to the power 5, so we have to solve it in n log n time complexity. Okay, I think this is a problem of heaps, but let's see how it goes. Okay, so we have -1, 2, and 3. What I can do is since I have k equals to, I think in this case the k was equals to 2, so I can fire up to 2 bullets. So what I will do, like this is the closest monster, so uh, fire one bullet at this monster for sure to kill it. So in the first second, I will fire one bullet at this one and one bullet at this one. So it will have. I don't think I can survive this. No, 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 no. I can survive this. Oh, sorry about that. Sorry for the noise. Now, what can I do? Like if I had a nearest monster, like let's say my nearest monster is at distance d1, and it has health ai or a1, ai. Okay, let's say di and ai. um I have, like, if ai is greater than di times k, then there is no chance of survival, right? So this is one case. Um, this is one of the cases. So first of all, I should eliminate this possibility. Okay, what is this? Problem C is changed, doesn't matter. Now what I can do is, first of all, I should traverse, and then I have to check if my xi times k, because minus 1, okay, the absolute value of this is actually less than a of I. So if this thing ever happens, then I have to see out. What do I have to see out? Yes, no, yes, no. Let me take all the inputs. Okay, then I will see out a no with an endl and return. Okay, so if this is the case, then I am for sure that I will not be able to survive. Okay, what is the next case? Like, okay, if it was less than, then I will probably need some bullets to kill it. Okay, so in the first second, like let's say I had a monster at d1, the smallest distance at d1, and I had k bullets. Okay, yeah. Now what? So, okay, I think this is a simple sorting problem. What I can do is basically, let's make a vector of pair intent. Okay, and let's call this L, and then for I, L dot pushback. Pushback of what? Two things, x of I, comma L of I. So first of all, I should say, why is this giving me errors? The function calls steady vectors. I'm not sure. Does this work? Yeah. So let's say x of I, comma L of I. Yeah, this is working. And let's actually take absolute value, because it doesn't matter whether the monster is coming from left or coming from the right. Yeah, so I think this works. Std vector long int. I'm not sure why this is happening. Let's say L of I is equals to this. I think I can now make this like x of I, comma L of I. Yeah. We have a vector of pair intent, and I called it n. Oh, sorry, it should be a of I. My mistake. Let's take the absolute value of x of I, because it doesn't actually matter. Now what I will do is I will first sort it, because I want to uh, okay, it is not in Python. So let's say L dot begin, comma L dot end. Okay, so now we have sorted the monsters according to the distances that we have. Okay, so int, let's say current is equals to 0, so the current number of bullets is 0. Now for I in range n, what I will do is I will have to first try to kill the monster, right? So the monster that is the closest to me, I will have to kill that monster first. And to do that, what I can do is, okay, let's say, like, if obviously if my L of I dot first, uh, what happened? If L of I dot first times the distance times k okay, plus the current number of bullets that I have fired at him, okay, is greater than L of I dot second, then I have to see out a no and return. Otherwise, what I will do is first of all I will have to say like, okay, L of I dot second, let's say minus equals to this whole thing, okay. So whatever was the current number of uh, whatever was the amount of that it required, I will fire at him, and the if it was negative, I will say absolute value of the amount that is left with me. So I will say absolute value of L of I dot second. So does this work? See out yes, and let's actually try to run this. So we have a no, yes, no, no. We have exactly opposite situation. Why is that? Let's try to debug this. Okay. Let's see what I am actually getting as my debug at my in my debug statement. Let's say for the only the first test case. Mm, let's see my debug L. So first I get 1 comma 1, then 2 comma 2, and 3 comma 3. Then I went for iron range. Is this loop even working? Yeah, I is 0. Then okay, is less than this, then I have to see out yes, otherwise, yeah. So currently I will have one bullet left because I fired at it. Now I will have fired four bullets, so I have three bullets left. Now I think this is working. Let's remove the debug lines and let's actually make it 4. So I'm getting a lot of yes now. So let's see, let's actually remove this test case and debug this. What happened? Yeah, the answer should be yes, no for this test case. Let's see why. Let's say debug L. So we have 1 1 and 1 1, and in this test case I can only fire one of 1. So what am I getting? Okay. Okay, so I basically fired at that at this one. Now, once I have fired it, it will have moved towards me, right? Yeah, I also need to consider the case that it can move towards me also. So since I have fired at it multiple rounds, it will have already moved towards me, and now I can't actually fire it because this is the second because this is the it has already moved so much towards me, but uh, I also need to check for one more thing. If L of I dot first, yeah, now it is the absolute value minus I plus 1, okay, minus I plus 1 is less than 0. So if it is less than 0, this is one thing, and also, okay, and what should I say? L of I dot second is greater than cur. So I can't actually fire the number of bullets, the left number of bullets. So then I have to see out a no and a return. So now it is giving correct answers. Let's actually make it 3 and see. So we are getting no, yes, yes, no, yes, yes. I think this should be 4. It is failing for the last test case, that is this one. So let's remove this and debug it again. Okay, so we had 1 1 2 2 and the k is 1 for this test case. Obviously I can't fire at it. So I will kill this monster first, but now it is at position 1, and if even if I fire it, fire at at this one, even if I fire at this position, I think what I'm doing is wrong. Let's actually try to rewrite everything. First of all, I need to check, like, okay, you are here, right? I can say first of all L of I dot second minus equals to minimum of cur comma L of I dot second. So I have subtracted the number of points that I could have subtracted. Now if L of I, so if these two cases are there, then I have to see out a no with a slash n and return. Now, okay, that was one case, but now I have to check, like, okay, if this was not the case, then I've already fired the number of bullets that I needed. So what I will do is, okay, let's do one thing. L of I dot first dot second, like it is now this guy is actually closer to me. So what I can do, and it is actually this much closer to me, so I can say L of I dot first minus equals to I plus 1. So actually it is closer to me now. Okay, and now I will have to fire some bullets at this guy, right? So if L of I dot first times k is less than L of I dot second, then I will see out a no and return. Else else what I will do is I know that I can kill this one, right? Actually no fired any rounds, so I will say minus equals to num, the number of rounds that I fired at this guy, right? And now I will have to say, like, okay, I this guy is now actually closer to me. Now I can say, can I fire k rounds if I can't actually kill it? Otherwise I will fire some rounds at this guy. Okay, and let's say cur, uh, I also want to minimize my cur, like whatever the number of rounds that I fired. So cur is equals to minus equals to minimum of, I mean this became 0, right? Let's actually call this something else. Let's say int d is equals to the difference. So that is that, and uh, let's actually minimize this from both of them. So minus equals to d and cur minus equals to d. So I have minimized d from both of them. Now what can I do? Like, okay, if okay, now I have to increase my current variable. Like, okay, I came this side, and if I was able to kill it, I would have killed it by now. Okay. Now, if this is the case, then nothing can be done, obviously. and L of I dot second, otherwise I know this is greater than, or let's make it equal to, no, if it is equals to, then I will be able to kill it. But what now? What I can do is, okay, let's say cur plus equals to this value. First of all, I need to get the amount of k that I will need. So int new k that I will be needing here is L of I dot second divided by L of I dot first. And actually I want to take the seal of it, right? And now because I want to take seal of it, what I will do is, okay, we have this, so the int amount of bullets that I will need to kill it is equals to what? Since I am taking the seal of it, I will say L of I dot second minus equals to new k times, no, it might be less, right? It might be less than this. So okay, let's say we have okay, let's say that it has a health of 5 and it can move 2 steps. So clearly, if my k equals to 1, then I won't be able to kill it. But if my k equals to 2, then I can kill this, right? Yeah. Basically, I want to get what is the maximum number of steps that it will be able to move. So I want to say, let's say int steps is equals to L of I dot second upon k. So it will have to move like it. If I was able to say like 5 by 3 is 3 ones are 3 1.5 something. So I will have to take the seal of it. So let's take the seal of this thing. Okay. So if it was actually equal to, then it will move 2 steps. Otherwise, it will only move 1 step, right? So like 6 by 3 is 1 2, and 5 by 3 is also 1 2. So I will have to fire at least 2 rounds. Now at every step I am going to fire bullets, k bullets. So bullets is equals to steps times k. So I fired these bullets at this guy, but now I only want to, like, if L of I dot second is less than the bullets, I will say okay, let's take L of I. Let's actually make a difference. So int d is equals to bullets minus L of I dot second, and L of I dot second minus equals to d, and let's actually say num plus equals to the steps, so it has moved this many steps, and cur plus equals to d. Okay, so let's actually run this and see if it works. So now we are getting a no. Let's copy this thing again and try to run this. So now we are getting yes, no, yes, so that is the correct output. Let's remove the debug lines. Yeah, okay. Did I change something? Yeah, it is working. Let's actually submit this. Okay, so the B problem, monster attack, and C++20. I hope it doesn't give me a wrong answer. Okay, it's still testing. Yeah, we got a correct answer. Let's move on to the next problem, that is find B. Okay, an array A of length m is considered good if there exists an integer b of length m such that the following condition holds. So summation of ai, okay, an array A of length m is considered good, there is an integer b of length m such that, okay, and ai cannot be equals to bi for every index, okay, and bi is greater than 0 for every index. You are given an array C of left, and the element, each of this element is greater than 0. You have to query Q the ith. During the ith query, you have to determine whether the subarray CL to CR is good. Okay, so this is a range query problem. Now let's first actually copy this whole thing, and let's copy the expected output also. Okay, now how many people have actually solved this problem? Let me just check it. Okay, so 1400. So this is a doable problem, I think. Find B. Yeah. Okay, so we have in the second line we want to print second line for each test case contains C1 to Cn. Then we have Q queries, and we want to find that if some number is good or not. Let's actually see, like, if we have an array, when do we get to know 1 2 1 2 3 4 5? So if we have something like, let me remove this. So if you have 1 2 1 4 5, so 1 2 1, and then it is asked like if this array is good or not. Is there any explanation for this? No. An array A of length m is considered good if there exists an integer array B of length m such that the following condition holds: AI not equals to BI. Okay, so the every element of this array is like this. So what I can do is 1 1 1 1, and whatever the sum of this whole thing is, let's say it is 1 2 1 plus 2 is 3 4 8, 8 plus 5 is 13, and let's say 1 2 3 4, 4 plus 9 is 13. So I can find such an array, but the problem is these two can't be equal. So I will have to increase this by 1. Actually, what I can do is, let's take the sum of it. Let's actually make this an average, something like, or let's try to find the one for no. So we have 4 to 4, 1 2 3 4. So if we have only one element, then there is no point, and 1 2 3 we add this. So if we have 1 2 1, so why is this not a correct answer? Why can't we get why can't we get for this? So if we have the sum is equals to 4, number of elements is 3. So what is the average? Now the average is, how should I say this? So 4 by 3 is 1, right? So if we have 1 1 1, and whenever I encounter the same, I can increase this by 1, but then I will have to decrease the some other element by 1. So if we have A1, A2, A3 till AN, so what I can do is, let's first take the how much time do I have to query this? So CI is still 10 to the power 9, that is okay. The stress case contains N and Q, so we have 10 to the power 5 queries, and we have to query this in big of log n time, and we just need to find yes or no values, nothing else. Okay. So if we have 1 2 1 4 5, let's see. If we have 1 2 1 4 and 5, like, obviously for 1 comma 1 the answer is no, because the sum is 1 and I can't do anything about it. What if we have 1 comma 2? So if you have 1 comma 2, I can start with 1 1, but now the sum is not equal, and to make the sum equal I can make this. Yeah, yes, I can do that. So I think the logic is simple. If we have 1 2 1, then there is 1 is the majority element, so we can't have that. If we have 1 2 1 4, then now 1 is no more a majority element. So I can simply put 2 and 4 here. Yeah, I think we just need to check if there is a majority element in L2R. if we find that in the region L2R there is a majority element, then we can't do anything about it, and the answer will be simply it, right? But how do we find majority element for all the ranges? How can we make a segment tree out of it? I mean, I can Google for answers maybe. Because if we have a major, let's actually try to prove this. Like, if what can we get a different case? Let's say we have 3, 3, 3 and 1, 1. Can I make something out of it? Let's say I try putting 1, 1 here and 2, 2. So 3 plus 3 is 6, 7, 8, 9, 10, 11. 2 plus 2 is 4, 5, 6. 2 plus 2, 4, 5, 6. 6 plus 5 is 11. So this array actually works. So no, that was not the idea of this problem. So let's say if we have 1, 1, 3, 3. How can we say that it will never be possible? I mean, 1400 people have solved it, so I'm not sure. This must be an easy problem. Let's not actually focus on the rank, and let's try to solve the let's keep trying to come up with approaches. Okay. I don't think that. Okay, first of all, the sum should be equal, and these two should not be equal. What does this mean? That when I don't want it to be equal, maybe I can shuffle the elements. And if I can't shuffle the elements, let's say in here I know I can't shuffle, because let's say 1 1 3 3 3, then even if I say 1 1 and 3 3, I am left with a 3 here. So I can clearly decrease this by 1 and increase this by 1, right? One thing I am sure is I can increase this by 1 and decrease this by 1. That is also correct. Yeah, I think mostly it will exist because there is no bound on C. I think it will only happen when I have number of ones is too much and there is only a 2. So if this is the case, then let's say since I had 1 1 and 2, what can I form from this? I can say 1 1 and 1, but no, if I try to shuffle it, it will become 2 1 and 1. But now to increase this value, increase this 1, I don't have a choice, because even if I decrease it, it will become equal. So I think only case is, let's say we have 1 1 and 2 at the end. So if this is the case, then maybe let's say 2 2s, like this. If this is the case, then obviously if number of 2s is greater than number of 1s, then we have something. Let's say 1 1 and 2. So this works. If we have 1 1 and 3, does this work? Like we have 1 1 and 3, then we have 3 1 and 1. Now what I can do is I can include 2 and 1. So this actually works. Yeah. So I think it only say no is only for if you have something like 1 1 1 1 and then 2 2 2 2, and such that the this is such that the, what should I say, like, I think what I can do is I can keep a count of ones and twos, and then, and obviously if the can't do anything about it, so that is also a case. So should I make a segment tree? Maybe I can also do this using prefix sums. Yeah, I will think I will do it using prefix sums. So if we have int n and q, scene n and q, vector int a of n for I, scene a of I. So So first of all is then I want to count the number of ones in that array. So let's say count one. Let's say vector int count one of n plus one and count two of n plus one. Okay. Yeah. Is there any other case where it will not work? Let's say we have 3, 3 and 100. I can simply say 1, 1 and yeah, I think this will always work. So it doesn't actually matter. And now for I in range n, obviously I will say, let's say count 1 of 0 is equals to 0 and count 2 of 0 is also equals to 0. If count 1 of I is equals to count 1 of I minus 1, let's start from 1 and go till n, plus 1, and now count 2 of I is equals to count 2 of I minus 1 plus a of I equals 2. Okay, so we have this. Now let's say while q minus minus, and now let's take two integers l comma r, c in l and r. If l and r are equal, then I will simply see out no. So that is one case, and continue. Now if now there is a case like, okay, let's say int num1, so the number of ones will be equals to count underscore 1 of r minus count underscore 1 of l minus 1.